Hi students, welcome to my channel. In this video, we are going to discuss another linear data structure, queue data structure. Previously, we discussed about linked list data structure and stack linear data structure. In this video, we are going to discuss a queue data structure. So, what is a queue data structure? It is a linear data structure in which the operations performed are first in, first out manner. This is the first important characteristic of queue data structure. The operations are performed in, first out manner, and it consists of two ends. One is rear end and another one is front end. Whereas in stack, if you observe, stack consisting of only one end. That end is called as top of the stack. Whereas queue consists of two ends, rear end and front end. So rear end, here we can perform insertion operation using rear end. We will perform deletion operation by using front end. That means it is unlike two stack data structure. So both are performed at top of the stack. But in queue data structure, so insertion we will do at rear end, deletion we will do at front end. So now, and what are the operations performed? The operations performed on queue data structure are two operations we can perform on queue data structure. One is enqueue and another one is dequeue. Two operations are performed on queue data structure. These are the main important characteristics of queue data structure. So queue is a linear data structure in which the operations are performed in the manner of a FIFO. FIFO means first in, first out manner, and it consisting of two ends, rear end, front end. So rear end is inserting end, front end is deleting end, and we can perform the operations on these items. So on whatever the data present. So the operations performed are enqueue and dequeue. Diagrammatically, queue is represented like this. Two ends are there, no? So like this. So here the elements are inserted. In this direction, elements are deleted. Generally, in ticket reservation counters, nowadays no one is standing in the queue and buying the ticket. Everything is online. Okay, but in previous days, so in olden days, whenever we want to buy a ticket, we had to stand in the queue. So then only we can buy the ticket, then only we can watch the movie. Okay, so now, so like that, so whenever you are taking a ticket by standing in the reservation, by standing in the ticket counter, so one end is inserting end and another end is deleting end. So after taking the ticket, we will come out of the queue na? In the same manner here also. So this is inserting end. We are entering into the queue. After buying the ticket, we will come out of the queue. So it is inserting end. This is insertion. And this is deletion. What is insertion end? Insertion end is called as rear end. Deleting end is called as front end. So diagrammatically, if you want to represent like this, we will represent the queue data structure. Now we will discuss one by one operations on queue data structure. Totally how many operations? Only two operations. One is enqueue and dequeue. So first one is enqueue operation. Enqueue operation means inserting an element at rear end. Inserting an element at rear end of the queue. Rear end of the queue. Inserting an element at rear end of the queue is enqueue operation. Okay, so now we will take an example how the insertion operation can be performed in queue data structure. So initially queue is empty. maximum how many elements we can insert? Maximum 4 elements we can insert into the queue data structure. So diagrammatically I am representing like this. So 4 elements maximum. So 4 elements present. This is 0, 1, 2, 3. Initially there are no elements present in the stack. So front and rear are present at -1th position. So now here. Okay. So this is front end and this is rear end. No elements are present in the stack, no. So that's why here both are present at -1 position. Okay. Now we want to perform one by one operation. Enqueue of 10 I want to perform. So in which position we can insert? We can insert in 0th location. But rear is present in -1th position na. So what we will do? We will increment rear. So we will increment rear. Then rear will come to this position and then we can insert. Then how can we insert and how queue looks like? See, queue is nothing but an array. Stack is also nothing but an array. But both are arrays. Know what is the difference? Organizing way is different. Stack organizing way or operations performing way is last in first out. Stack data structure, the operations performed on what basis? Last in first out. But we are performing operations on array only. But the organized way, storage way is different. So in queue data structure, what is the organized way of queue data structure? First in, first out data structure. Okay. So enqueue of 10. So this is an array. So while performing insertion operation, that means enqueue operation, so we won't consider front. Why? Because that is deleting end. So now rear is incremented. Rear will come to 0th position and then insert the element into the queue. This is the first insertion operation. Now second insertion operation. Enqueue of 20. Another insertion operation I want to do. How can we perform? Here in the same place, if we are inserting na, then it overrides a 10. 10 will be removed. So we should not do like that. Then what shall we do is we will increment rear. So the array size we have already defined. A maximum array size is 4. That's why here I am representing 4. Okay. 0, 1, 2, 3. Now here it is 10. Rear is incremented and insert the element. What is the element here? 20. Front. Don't bother about front. Why? Because the front we will consider only at the time of deletion operation. Now again another enqueue operation, enqueue of 8. Then what shall we do? Simply we will increment rear position. Increment rear position. Now array size is 4. 0, 1, 2, 3. We are incrementing rear position, rear. So 10, 20 are already there. Now increment rear and then insert. So here it is 8. Now enqueue of some 9 we want to insert. So 9 we want to insert. How can we insert 9 into the queue data structure? Same, increment rear and then insert. Now the queue data structure is 0, 1, 2, 3, 10, 20, 8. Now rear is incremented and 9. Now one more enqueue operation I want to perform, like enqueue of some 11 I want to perform, which is not possible. Why? Because array size is 4, queue size is 4. 4 elements are inserted. That means rear equal to max minus 1. What is our max value? 4 minus 1, which is nothing but what? 3. So whenever rear is becoming max minus 1, then queue is full. Then queue is full. Insertion or enqueue is not possible. Enqueue is not possible. that is enqueue operation. Now coming to dequeue operation. Now dequeue, second operation on queue data structure, that is dequeue operation. What is dequeue operation? Dequeue means deleting an element present at front end. Deleting an element present at front end. Deleting an element present at front end is called dequeue operation. See, now these are the elements present in the queue data structure 10, 20, 8, 9. Now these are the elements. Now we will take those elements only. 0, 1, 2, 3, 0, 1, 2, 3, 10, 20, 8, 9. These are the elements present in the queue data structure. And rear, don't forget to mark front and rear positions. So now front is present at -1th position. Now we will perform dequeue operation. We will perform dequeue operation. How to perform dequeue operation? So what is queue data structure? Queue data structure is first in, first out. So among all these elements, which one is the first inserted element? 10 is the first inserted element. So 10 is first inserted element. So which one we have to delete? 10 we have to delete. Then what shall we do? We will increment front position as front is present in -1th position. We will increment front. So then the queue is queue size 4, 0, 1, 2, 3. So 20, 8, 9. Here deletion operation is nothing but increment front, that's it. Now rear is as usual. So while enqueue operation we are not considering front position. While dequeue operation we are not considering rear position. Rear is present wherever already there. Okay. Now one more dequeue operation I want to perform. So after this, what is the next inserted element? 20 is the next inserted element. What is our queue logic? First in, first out data structure. That means the first inserted element will be deleted first. Okay. So here, what shall we do now? So just increment front. Then the queue is array size is 4, 0, 1, 2, 3. 20 is removed as the front will come to this position. Here 8 and here it is 9. Okay. Then next. One more time. This is first dequeue, second dequeue. Third time dequeue operation we are going to perform. Dequeue. Now what? Rear is present here only. Don't forget. So now increment front position 0, 1, 2, 0, 1, 2, 3. So now increment front, that means this element is removed. Rear is present here only, the element is 9. Again dequeue operation we want to perform. Then our queue elements 4, 0, 1, 2, 3. Increment front will come to this position. And rear already here only. But this element is removed. So one more time dequeue operation we want to perform. But not possible. Why? Because queue elements all are deleted. What is this called as? Queue is empty. Queue is empty. Deletion is not possible. Deletion is not possible. So like that you can perform dequeue operation. Enqueue operation, dequeue operation. Okay. So these are the two main important operations performed on queue data structure. Now by using arrays, how can we implement this queue data structure? So we will implement the queue data structure using arrays. So we will implement queue data structure now. New file. Now we are going to implement the queue data structure. See, here in online compiler I am doing that queue data structure implementation. See, online GDP. I am using online GDP. See here, and here select the language. Here select the language, C language. Then you can do the program here. So no need to install anything. If you want to do the program, no need to install anything here. So directly you can go to online compiler and you can execute the program. Now see how can we execute. I'm writing command lines, program to implement queue data structure using arrays. Now start your header file, hash include stdio.h, and I'm taking maximum how many elements you can insert into the queue data structure, whether you want to insert 5 elements or 10 elements or 4 elements or 6 elements, how many elements you want to insert. So hash define some max, I'm taking max of some 5 elements I want to insert. Okay, so and then you can write void enqueue operation. Enqueue, which element you want to insert. So integer ELE. So while performing insertion or enqueue operation, what we had to check? We had to check queue full condition. We discussed what is queue full condition. Queue full condition is if rar is equal to max minus 1, then printf queue is full. Else, then how can we insert? So just increment rar position and then take our queue array variable name as A of in which position we have to insert? In rar position. Which one we have to insert? Element. That's it. So this is enqueue operation. Now similarly dequeue operation. Dequeue. Which element you want to delete? See, whatever the element you want to delete, you can't delete. Why? Because so in queue data structure, first inserted element will be deleted first. First element only we have to delete. Whatever the element you want to delete, that we can't delete in queue data structure. Okay. So now for deletion operation, we have to check whether queue consisting of some elements or not. That means queue empty. If queue is empty, then we can't perform dequeue operation. So what is a queue empty condition? We already discussed while solving the problem. So if front equal to rar, then printf queue is empty. Queue is empty. Else how can we delete? First we will display the element, whatever the element we are deleting, we will display to know which element we have deleted. Okay. So printf, new line I am giving, the deleted element is %d double quotes close comma, that number we want to print now, that's why %d. In which position? Front is initial at -1th position. Front is present at -1th position. Now 0th position element we have to delete. So that means front +1 position we have to display here. So front +1. Okay. So now increment front. Element we have to delete. That's why front incrementation. So close your dequeue function. Now we have to display whether operation performed correctly or not. We can know by using display function only. So void display. To display the elements stack, we had to check, not stack, queue, we had to check whether it is empty. If it is empty, display is not possible. So that's why again we are checking if front equal to rare printf queue is empty. Deletion is not possible. Okay, else now we have to display not one element. Queue may consist of more than one element. So that printf statement we have to repeat. So for that purpose I am taking for I equal to from which position to which position we have to display. Front +1 position and last element always present at rare. So that's why I is less than or equal to rare. Every time we are moving towards right side, na? That means I should be incremented. So I plus then printf %d/t comma e of I. Okay, this is display function. And then after display what shall we do? Just call the main function. Write the main function. So in main function, just to call those functions, enqueue of sum 10, enqueue of sum 20, I want to display. Again I want to perform enqueue operation of 30. Then I want to check what are the elements. And I want to dequeue. After deletion, I want to display what are the queue contents. Close this. Okay. Now, here in display function I we have taken that I we have to declare integer I, and array variable also we have not taken. So take that array as global. Why? Because that array variable, front variable, rare variable we are using throughout the program. That's why we will declare those three as global. So int a of max comma front equal to -1, rare equal to -1. Now see how to run in this online compiler. So just simply here only we will get. Okay, run the code. Some error, hash include stdio, typing mistake. So stdio.h, again run the code. In 46 line, see whenever error occurred, you don't panic. Read the error, understand the error, rectify the error. That's it. In 46 line, expected parentheses or braces. In 40, see all this. In online compiler, automatically these braces, whenever you are keeping open brace, automatically it will give closed braces. Okay, so extra braces here are there. Now see how many elements I have inserted. 10 or 20. 10, 20 I have inserted. Then 10 or 20 are displayed for this display. After that 30 enqueue and display. Then the elements are 10 or 20, 30. Display. Next dequeue. Which one will be deleted? 10 will be deleted. Why? Because of first in first out data structure. Then which one is deleted? 10 is deleted. After that again we want to display. So after deleting 10, the elements here are 20, 30. So output is not clear. So that's why here I will add some printf statement. Printf after enqueue. For short, I'm writing enqueue. Okay. And I'm giving a new line. Again here also, before display, if we have given clear idea, then it is easy to understand. Same printf after enqueue only, na? But this is, yeah, dequeue, and but this is after dequeue. Now let us check. Then it is easy to understand. After enqueue, see, after enqueue, 10 or 20 are inserted, 10 or 20. Next, again 30 is inserted, na? So again after inserted, 10, 20, 30. Here we have dequeue. So the deleted element we are displaying. After deletion, what are the elements? 10 is the first inserted element, that is deleted. What are remaining elements? 20 and 30. So 20 and 30 are displayed. Like that, you can execute the program. So without installing any software, online compiler you can use. In mobiles also, if you are not having laptops, in mobile phones also, you can execute same online compiler, online GDP, but don't forget to select the programming language. So hope you understand, students, the implementation of queue data structure using arrays. If you have any doubt, you please comment me in the comment box. Execute the program. Execute the program. If you are getting any errors, don't panic. Okay. So just read the error and see these 3 steps. Whenever you are doing the program, follow these steps. Read the error, understand the error, rectify the error. That's it. It will be solved. Okay. So hope you understand, you gain some knowledge by listening to this video. So if you like the video, please share with your friends and subscribe the channel to get more videos. Click on bell icon to get updated videos. Thank you, students. Have a great day. Bye.